Hey guys, today we're going to talk about Chapter 4, Lesson 4.1, Discrete Random Variables. So a discrete random variable has a finite or countable number of possible outcomes that can be listed. So this could be the number of texts that you sent in one night. You could count out how many there were. Continuous random variables have an infinite or uncountable number of possible outcomes that can be listed. That could be like the amount of time that you spent texting. It could be 1 minute, 2 minutes, 3 minutes, 3.5 minutes, 3 1/4 of a minute, 3 1/6 of a minute, 5 minutes, 1 hour and 36 minutes and 27 seconds. There's all these possibilities. On a number line, it would look like you having your kind of whole numbers listed out there. And then for the continuous random variable, so in these it would be at each of those lines. A continuous random variable is everything in between. So it doesn't just stop at the little notches. It's everything in between. So we're going to focus on those discrete probability distributions that are countable. So for a discrete probability distribution, you list all possible values the random variable can assume and its probabilities. It must satisfy the following conditions. The probability of each value of the discrete random variable is between 0 and 1 inclusive, so it can be 0 and it can be 1. The sum of all possibilities is 1. So we are going to look at a discrete probability distribution of about how many children are in your family. So I've got some data here for 1 child, 2, 3, 4, 5, and 6 plus. So when you add that all up, you get 23 people in the study. So to find the probabilities, for 1, I do 2 divided by 23. Then for 2, 5 divided by 23, 3 divided by 23, and so on, until you get them all filled in. And then it asks if this is a valid discrete probability distribution. Yes, all probabilities are between 0 and 1. And if you add them up, they'll add up to 1. Or as close one as you can get with our rounding. Okay. Next, it wants us to make a histogram to display the information. So I've got our axes here. So the probability for 1 is 0.087, so that would be just under there. 2, 2.17 would be just over the 2. 3 is going to be about here. 4, a little over halfway between 2 and 3. 5 is the same as 3. And then 6. So there's a histogram of our distribution. Okay. Describe in words what the probability of x is greater than 3 is, and then find probability of x is greater than 3. So in our distribution, x is the number of children. So probability of x greater than or equal to 3 is the probability that you have 3 or more children. 3 or more children in the family. Three or more children in the family. Okay. And to find that, you would just add up your probabilities for 3, 4, 5, and 6 plus. So probability of 3 plus probability of 4 plus probability of 5 plus probability of 6 plus, which gives us 0.695. Next one, describe in words what probability of x is greater than 3, and then find probability of x greater than 3. Since it's no longer x is greater than or equal to, it takes out that 3. So it's the probability of more than 3 children. Okay. So that would be probability of 4 plus probability of 5 plus probability of 6 plus, which is 0.565. Then it wants us to find the average of all of the values. So we're going to add up all of our x values. So 1, 2, 3, 4, 5, and 6. We're just going to take 6, even though that was 6 plus, just because that's all we can do. So that gives us 21. And then we divide it by our 6 numbers, which gives us 3.5. So does that 3.5 tell us the average number of children in the families of the students in our classroom? No, because it doesn't take into account how many people had 1, 2, 3, 4, 5, or 6 plus. It's just looking at the average of those 6 numbers. So we have a formula for that, and we're going to see that next on our mean expected value. So for our mean expected value, it's the average of a discrete probability distribution. So it's x bar, or mu, equals the sum, that's sigma, it stands for sum, of each of our x values times the probability of that x value. Okay, multiply each x by its probability and add. Okay, so down here, our x bar is going to equal 1 times the probability of 1 plus 2 times the probability of 2 plus 3 times the probability of 3 plus 4 times the probability of 4 plus 5 times the probability of 5 plus 6 times the probability of 6. Okay, so we get 1 times 0.087 plus 2 times 0.217 plus 3 times 0.130 plus 4 times 0.261 plus 5 times 0.130 plus 6 times 0.174, which equals 3.649. So the average number of siblings of the students in the class is 3.649. We can do this using technology. In your calculator, if you go to Stat Edit, under List 1, you're going to list the x's. So that's 1, 2, 3, 4, 5, and 6. And then under L2, you're going to list the probabilities. Then you're going to go to Stat Calc 1var, and List should say L1, and then Frequency List should say L2. And once you've done that, you can see your average. So it'll give you that x bar, which is your mean expected value we just did above. It's also going to give you your standard deviation and your variance. So if we run our information from above through, our standard deviation, the average distance that each data point is from the mean, that's our sigma for these. So our sigma says 1.58. This is the standard deviation of the siblings in the class. And then variance is the standard deviation squared. It's another measure of the spread of the data. So all you do is take your standard deviation and you square it. So we'll do 1.58 squared. Gives us 2.50. So check for understanding. Go ahead and try this back page and then come back for the answers. Okay, hopefully you got a chance to try those problems. here's part of our answer. Go ahead and pause it to check yourself. And then here is the rest.